Hi everyone, let us now solve this question under polynomial. Given that x minus 2 is a factor of f of x, where f of x is 2x cubed plus x squared minus 7x minus 3b. Alright, in question A, we are asked to find the value of b. Then in question B, we are asked to factorize f of x completely. And then the last part is to solve for x, the equation f of x equals 0. Now let's start quickly with the first part. F of x is 2x cubed plus x squared minus 7x minus 3b. That is a polynomial. It's a polynomial of degree 3. And we're told that x minus 2 is a factor of f of x. If that is a factor of f of x, it means from the factor theorem that f of 2 must be 0. All right? The factor theorem is a result, a particular case of the remainder theorem. All right? That means if f of x divided by x minus 2, the remainder will be 0. Okay, so this is a equation that will enable us to get the value of the constant b. So let's work out f of 2 and then equate the result to 0, and then we will be able to solve for b. So f of 2, that means wherever I find x here, we're going to put 2. So we have 2 into 2 cubed plus 2 squared minus 7 multiplied to 2 minus 3b. We expect that to give us 0. 2 cubed is 8 multiplied to 2 is 16. 2 squared is 4. 2 multiplied to 7, so we have 14 minus 3b giving us 0. All right, 16 plus 4 is 20. Okay, 20 minus 14 is 6. So we have 6 minus 3b giving us 0. If we take this negative 3b that way, we're going to have 6 is equal to 3b. So to have b, we have to divide both sides by 3. 3 here 1, 3 there 1, 3 here 1, 3 there 2. Therefore, the value of b is 2. Okay, the value of b is 2. Now, let's take the second part of the question. Let's take the second part. We are asked to factorize f of x completely. Now that we know the value of b, so f of x now becomes 2x squared plus, 2x cubed plus x squared minus 7x minus 3 multiplied to 2 becomes minus 6. So this is your f of x. So we are called to, let's write it very well. Let's write it very well. F of x is 2x cubed plus x squared minus 7x minus 3b. b is 2, so 3 multiplied to b is 6, so say minus 6. So that is the true expression for the polynomial f of x. Now we are asked to factorize this polynomial. Okay, it's not the same thing as finding the solution. Okay, we don't get mixed up here. If we were equated to 0, then we will say solve this polynomial expression. So here we are doing factorization. Okay, so how do we proceed to get all the factors of f of x? F of x is of degree 3. It's a cubic polynomial. A degree 3 polynomial supposes or means that that polynomial must have 3 factors. So we are expected to get 3 factors. Already in the question, one of the factors was given us. X minus 2 is one of the factors. So we are going to carry out Euclidean division. We're going to carry out f of x divided by x minus 2 so that we can reduce the quotient. We can reduce the power. The quotient that we'll obtain will be a quadratic expression, which will be a lot easier for us to factorize to get the remaining 2 factors. This is already the first factor. So let's carry out that Euclidean division. Okay, so let's write it. So we're going to divide by x minus 2. So we'll have x minus 2. F of x is 2x cubed plus x minus plus x squared minus 7x minus 6. Okay, this is the Euclidean division. So what are we going to write up here so that when we multiply back, we will get exactly 2x cubed. So our aim is to be able to have 2x cubed here so that when we subtract, we'll have 0 here. We'll have 0 here. Okay, so we look for that expression that when we write here and when we're multiplying backward, we're going to have 2x cubed here. So you can see that it should be 2x squared, right? 2x squared multiplied to x will give us 2x cubed. 2x squared multiplied to negative 2 give us negative 4x squared. Okay, so that when we do now this subtraction, 2x cubed minus 2x cubed, we have 0. Then we'll come over here, x squared minus 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 gives plus. So 1x squared plus 4x squared gives us 5x squared. Okay, this is 0, it's not negative, right? So we'll have 5x squared. So we'll bring down negative 7x. Okay, now we are at this level. Again, our process remains. So what are we going to write up here? So that when we multiply back, we're going to have 5x squared here. Okay, look at it, this is x. So we must multiply by 5x. So we write plus 5x. So that 5x multiplied to x will give us 5x squared. 5x multiplied to negative 2 will give us negative 10x. And we're doing subtraction. So that 5x squared minus 5x squared, 0. And then negative 7x minus 10x. Again, minus become plus. So we say negative 7x plus 10x. That gives us 3x. We'll bring down negative 6. What are we going to write up here? So that when we multiply back, we're going to have 3x. It should be plus 3. So that 3 multiplied to x will give us 3x. And 3 multiplied to negative 2 will give us negative 6. All right? So we have the same expression up and the same expression down. Something minus itself give us 0. All right? We expect to have 0 as a remainder because we were told that x minus 2 is a factor. All right? If this actually were a factor of this expression, then we expect this division to end with 0 remainder. All right, so f of x now can be written as, so f of x now can be written as x minus 2 into the quotient there, 2x squared plus 5x plus 3. Okay? All right, so we have a linear factor. This is already one factor multiplied to a quadratic. You see, the degree has gone down from degree 3 to degree 2. So the remaining two factors are here. So what we need to do now is to factorize this quadratic. Okay? This quadratic is going to give us the remaining two factors. So how do we go about that? All right? Now, if we look at it, we have a, c. We want to use the factorization method, not the quadratic formula. We want to use the factorization method. Our A is 2, our B is 5, and our C is 3. All right? AC will be what? 2 multiplied to 3 is 6. Now, let's get those factors of 6. All right? We'll get those factors of 6 whose sum will give us 5. Which are those factors of 6 that when we add them up, we're going to have 5. You see, the factors are 2 and 3. Okay? The factors are 2 and 3. So we will now rewrite this quadratic. We will now rewrite this quadratic and replace this 5 with 2 plus 3. So this becomes 2x squared plus 2 plus 3x plus 3. All right, so that so that let's take it up again. There we have 2x squared. Let's open this bracket. 2x multiplied to x is 2x. 3 multiplied to x is 3x. So that 2x plus 3x give us the same 5x. And then plus 3. Okay. So we're concentrated only on this quadratic now. This linear is already a simple factor. So we'll leave it there. We'll concentrate there to get the remaining two factors. Okay. So look at it. We consider the first two and then the next two. All right. If we look at the first two, we see that 2x is common. So we can factorize out 2x. When we factorize out 2x from 2x squared, we have x. When we factorize out 2x from 2x, we get plus 1. All right. If we take the second, we see 3 is common. So if we factorize out 3 from here, we got x. If we factorize out 3 from there, we got 1. All right. Look at it. We have x plus 1. X plus 1 is common. So we continue the factorization process. So we bring out x plus 1. Okay. When x plus 1 is brought out from this, we're left with 2x. And then when x plus 1 is brought out from this, we're left with positive 3. Okay, so look at it. We now have x plus 1 into 2x plus 3. This is linear, just like the first factor was linear. Therefore, we have finally found the three factors. And so f of x in its factorized form will be, we start with the first factor that was given in the equation, x minus 2, into these other two factors. We have x plus 1, 2x plus 3. Okay? So this is what we mean when we say we should factorize f of x completely. That means express f of x as product of its linear factors. We have 1, 2, 3, which conforms to the degree of f of x. It's a polynomial of degree 3. So we were supposed to have 3 linear factors. Okay, let's take the last part of the exercise. The last part, question C. Let's take the last part of the exercise, question C. We are asked to solve for x in z. This is a set of integers. We want to solve this equation. F of x equals 0. F of x equals 0. All right? Now, this is the same as saying that what? Remember earlier on we factorized out f of x completely as x minus 2 into x plus 1 into 2x minus 3. So we write that as fx minus 2, x plus 1, 2x minus 3 equals 0. All right? Okay. No, plus 3. Sorry. Okay. If you multiply out all of this, you will get back to the function 2x cubed plus x squared minus 7x minus 3b. So this is f of x in its factorized form equals to 0. We have the product of 3 linear factors giving us 0. We have the product of 3 linear factors giving us 0. That means that what? Either this linear factor is 0, or this is 0, or this is 0. So either x minus 2 is 0, all right? If x minus 2 is 0, that implies that x is equal to 2. Or x plus 1 is 0. If x plus 1 is 0, that implies that x is equal to negative 1. Or 2x plus 3 is 0. All right? Which therefore implies that what? If we take this plus 3 to the right hand side, we'll have x equals negative 3, and we will divide both sides by 2. we'll have x equals negative 3 all over 2. Okay, so which are the three solutions or roots? Okay, another word for solution is root. We could also be asked to find the root of f of x equals 0 or the solution of f of x equals 0. So which are the three roots? We have 2, -1, -2/3. These are the three solutions for that polynomial equation. But look at the condition here. We were asked to find the solutions in the set of integers. What are integers again? Integers are simply positive and negative whole numbers. Whole numbers, no fractions. That automatically means therefore that what? If we were to give our solution in Z, then this member, which is not a whole number, is out. And so we'll say in Z, x can either be 2, okay, or x is -1.